Okay, guys, greetings. This is the back half of 12.4, where we need to talk about inverse matrices. So first, to introduce a term, an identity matrix. An identity matrix is just a square matrix, like that one or that one, where there's just ones down the diagonal and zeros everywhere else. Okay, an identity matrix is kind of like a one with numbers. If I multiply a matrix times an identity matrix, it equals itself. Kind of like if I multiply a number times a 1, it equals an identity matrix. Okay, so that's the big idea. Okay, but inverse matrices have several different properties. But first, I want to be able to show that two matrices are inverse matrices. Well, if these are inverse matrices, if I multiply them, they make an identity. So I need to come off here to the side and multiply 1, 1, 0. Multiply A for 3, 0, 2, 1, negative 1. I need to multiply that by the other matrix, right? 3, 1, 0. And if they are inverses, I should get an identity, right? Perfect. Okay, so let's look at that. So remember, I have to multiply a row times a column. So that's going to give me, and I'm gonna put two forms here so I can pick this apart. Okay. Okay. So I go 1 times 3. That's 3. 1 times 4. That's 4. 0 times negative 2. That's 0. And 3 plus 4. Well, wait. Oh, I just noticed a mistake. I was going to say 3 plus 4 is 7, and that's not an identity. So I want to double check myself. And do you see what I've done wrong? I see what I did wrong, just barely. Check out the matrices. Check out this matrice. 3, 4, negative 2. So negative 3. I'm going to check. 1, 4, 2. Check. 1, 3, 1. Check. 0, 0, negative 1. Okay. Negative 3, 4, negative 2. Okay. 1, negative 1, 1. 0, 0. Okay. I got them all. So 1 times negative 3 is negative 3. 1 times 4 is a positive 4. And 0 times negative 2 is 0. 3 plus 4 is 1. I'll be honest. I know that these are inverses because I've done this problem before, but I want to show you. Next, I want to multiply the top row times the center column. So 1 times 1 is 1. 1 times negative 1 is negative 1. And 0 times 1 is 0. So I've got 1 minus 1. That makes a 0. Top row, last column. 1 times 0 is 0. 1 times 0 is 0. 0 times negative 1. Hey, that's a 0. So that's a 0. Okay, cool. Now, second row, first column. 4 times negative 3 is negative 12. Here, 3 times 4 is a positive 12. So far, I've got nothing, right? 0 times negative 2 is going to be a 0. Perfect. Okay, second row, second column. 4 times 1 is 4. 3 times negative 1 is negative 3. 0 times 1 is 0, so I've got 4 minus 3 is 1. Second row, last column. I love this because the zeros are going to give me nothing, so nothing, nothing. 0 times negative 1 is nothing. Cool, huh? Okay. Now, last row, first column. 2 times negative 3 is negative 6, so that makes a 0. 1 times 4 is a positive 4. Negative 1 times negative 2 is a positive 2. And negative 6 plus 4 plus 2 is 0. Cool. Last row, second column. 2 times 1 is 2. 1 times negative 1 is negative 1. 1 times 1 is a positive 1. And 2 minus 1 plus 1 is... Whoa. Did I do that right? Because I should get a 0 here, right? So last row, second column. 2 times 1 is a positive 2. Okay. 1 times a negative 1 is negative 1. Okay. Negative 1 times 1 is another negative 1. There he goes. 2 minus 1 is 0. Cool. Okay, 2, 1. These times 0 is going to give me 0. And negative 1 times negative 1 is giving me a 1. So there it is. Check. Those are inverses. Okay, so if you multiply a matrix times another matrix and you get an identity, those two matrices are inverses. Okay, now I can solve an equation using an inverse. But in order to do that, I've got to find the inverse thing. So I have to set up, so for this, I want to find the inverse matrix of that. Now, I don't worry about the answers because inverse matrices are only, well, because inverse matrices to solve equations, I only use the coefficients. Okie doke? So if I set up this matrix to find an inverse, I have to write down the coefficients, 3, -3, 1, and then 1, 2, -4, and then -1, -3, 1, but I augment it to find the inverse, and I don't augment it with the answers right there. I augment it with an identity matrix, so 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the augmented matrix I use to find the inverse of that. Okay, so what I have to do is I'm going to use row operations to make this half an identity matrix. So I can add rows, I can subtract rows, I can multiply rows by a number, and I can switch rows around. So I use those kind of operations to make an identity matrix right over there, and whatever happens on this right side, this will become the inverse. Okay? So let's work through a couple of these. We'll start with something easy. Find the inverse of this matrix. So to do it, I have to set it up first. So 2, 4, -4, -7. Okay. Oops, I made a mistake because I didn't augment it, right? I need to augment it. And I augment it by going 1, 0, 0, 1. Okay. Now I want to make an identity over here, which means I want to make zeros. So I'm looking at this, and if I was to multiply this first row by a -2 and then add it to the second line, -2 times 2 is -4, plus the 4 is a 0. Okay, that works. -2 times -4 here is 8. 8 minus 7 is 1. Oh, that's cool. I didn't see that. I didn't see that was going to happen. -2 times 1 is -2, plus 0 is -2. And here, -2 times 0 plus the 1 is -1. Okay. And I still have got 2, -4, 1, 0. But now, check this out. If I go 4 times that line 2, that'll make a 4 right there, and I can add it to the -4. And I can get a 0 in that second spot there. So I'm going to just copy this bottom row down because there's nothing doing there. Nothing to do there. -2, -1. Cool. 4 times 0 is 0, plus 2 is 2. Awesome. Okay. 4 times 1 is 4. 4 plus a -4 is 0. Okay. 4 times -2 is -8. -8 plus 1 is -7. Okay. 4 times -1 is -4, plus the 0 is -4. Cool. Now all I have to do is I need to turn that 2 into a 1. So what I'm going to do is I'm just going to take that line 1 and I'm going to divide it by 2. So that will give me, bottom line is just the same, -2, -1. Top line, 2 divided by 2 is 1. 0 divided by 2 is 0. -7 divided by 2 is -7/2, or -3.5. Don't care. -4 divided by 2 is -2. There's your inverse. So the inverse is this right half. -7/2, -2, -2, -1. Cool. And I could check to make sure I got it right by multiplying this inverse times that matrix. I'll let you do that. Okay, I'm 99.9% sure they're right. So I'm going to move on because this takes a little more time to find the inverse of this. To find the inverse of that, wow, it's a 3 by 3. So I'm going to set up my augmented matrix, 1, 1, 0, 1, 2, 1, 2, 3, 2, boom, 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 boom. And I'll augment it with an identity, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and again, I want to make an identity matrix there. Okay. Now, I might do a couple things at once here, just for kicks. First, I'm going to get a 0 right here, where this 1 is in the second row. And I'm going to do that by going negative line 1 plus line 2. Okay, so if I do that, I'm going to make a new line 2. Negative 1 plus 1 is 0. Negative 1 plus 2 is a 1. Oh, that's nice. Negative 0 plus 1, that's a 1. I like 1s and 0s. They're nice. Negative 1 plus 0 is negative 1. Negative 0 plus 1 is 1. 0 plus 0 is 0. Cool. Now, while I'm doing that, I think we're to the point now where I can keep track of a couple things at once. I'm actually going to get rid of this 2 right here in the bottom left. And I'm going to do that by multiplying negative 2 times line 1, and I'm going to add it to that third line. So here, negative 2 times 1 is negative 2, plus the 2 is 0. Negative 2 times 1 is negative 2, plus 3 is 1. Ooh, I like that. Negative 2 times 0 is 0, plus 2 is 2. Negative 2 times 1 is negative 2, plus 0 is negative 2. Okay. Negative 2 times 0 plus 0 is 0. Negative 2 times 0 is 0, plus 1 is 1. And I still have my top one, 1, 1, 0, 1, 0, 0. Okay. I'm getting closer. I'm getting closer. Cool. Okay. Where else can I get a 0? You know what? I can get a 0 by going negative line 2 plus line 3. Because if I go negative 1 here plus the 1, that gets rid of that. Okay. So set myself up. Okay. I'm going to leave this top one alone. 1, 1, 0, 1, 0, 0. Now, I've worked with people the last couple of days, and they said, oh, you know what? If I multiply this by negative 1, I can get rid of that. Yeah, but I'd fill in that 0. So I really don't want to do that yet. I don't want to fill in the 0 if I don't have to. And these two zeros, when I combine them, will make a 0. So I'm just going to leave both of these top two lines exactly the same right now. And I'm just going to go negative 0 plus 0, 0. Negative 1 plus 1 on the second spot is 0. Cool. Negative 1 plus 2 is a 1. I love that because it made zeros and 1s. So this line is going to be done. Negative, negative 1. That's the opposite of that, which is 1 minus 2 is a negative 1. Negative 1 plus 0 is negative 1. Negative 0 plus 1 is 1. Okay. Whew. Okay, now check this out. I'm just going to make a circle. If I multiply that if I multiply negative 1 times that third line and add to the second line, that'll give me a 0 right there, right? Yeah. Okay, so let's rewrite this. So 1, 1, 0, 1, 0, 0. I feel like I'm talking binary code. Bottom row 0, 0, 1, negative 1, negative 1, 1. Okay, so here, negative 1, 0, 1, 0, 1, it's going to be a 0 and a 1. Negative 1 plus 1 is 0. Negative, negative 1 is positive 1 plus negative 1 is 0. Negative, negative 1 is positive 1 plus the 1 is 2. Negative 1 plus 0 is negative 1. Cool. Now I just need to get rid of this one right there, and I can do that by multiplying that second line by a negative and adding it to the first line. So if I do that, the bottom two lines aren't going to change. So I'm just going to copy the bottom two lines down. And once I get that done, I can work on making a new first line. There we go. So negative 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 0 plus 0 is 0. Negative 0 plus 1 is 1. Negative 2 plus 0 is negative 2. Negative negative 1, that's positive 1, plus 0 is 1. Cool. So there is my inverse. My inverse is 1, negative 2, 1, 0, 2, negative 1, negative 1, negative 1, 1. Cool. Okay. There's my inverse. Now, and I'm going to write that down just for a second because I'm going to need it here in a moment. So A inverse, that leads you to believe I'm going to look at the next slide, right? Yep. 1, 2, negative 2, 1, 0, 2, negative 1, negative 1, negative 1, 1. Okay. So, and that's the inverse of this matrix up there. That's 1, 1, 0, 1, 2, 1, 2, 3, 2. Cool. Okay. Now, let's move on. The cool thing with inverses is I can use them to solve a system. This system here can be looked at like this. This is a matrix A, where A is just the numbers 1, 1, 0, 1, 2, 1, 2, 3, 2, okay, times another matrix X, Y, Z, X, Y, Z, and that matrix equals a third matrix, matrix B, which in this case is just the answers. I can rewrite a system of equations as an equation of three matrices. Okay? In fact, if you were to multiply this matrix, this is a 3 by 1 matrix, by this is a 3 by 3 matrix, by this is a 3 by 1, I actually get this up here. Now, this is the cool thing. If I knew, just by some coinky-dink, the inverse of this, so I think, suppose I knew A inverse. Well, then I could multiply A inverse times each side. I could multiply A inverse here, and I could multiply A inverse here. What happens there is this cancels and makes an identity. And all I have is that X, Y, Z, this matrix, is equal to A inverse times this matrix B. Okay? So in this way, I can use the inverse to solve the matrix, because if I have this and I have this, I have the solutions. Now, check this out. Let me make it short. I view this, and I think, I suppose I knew the inverse. Well, if you remember the last slide, that was 1, 1, 0, 1, 2, 1, 2, 3, 2. We just found the inverse of this. I do know the inverse of this. The inverse of this is that thing that I just found, which I wrote down right here. It is 1, negative 2, 1, 0, 2, negative 1, negative 1, negative 1, 1. So if I take that matrix and I multiply it by the solutions of this system, the 20, 30, 55, I'm going to come up with something. Check this out. This is a 3 by 3 matrix. This is a 3 by 1. So if I multiply these two things together, and I can because these two numbers are the same, I'm going to have a 3 by 1 matrix. Okay, so I'm going to have a 3 by 1 matrix here. So let's take care of this. I multiply the first row times the first column. So 1 times 20 is 20. Negative 2 times 30 is negative 60. 1 times 55 is, 55, duh. I'm sorry, I'm being a little dumb today. 20 minus 60 is negative 40. Negative 40 plus 55 is 15. Guess what I just found out? I just found out that x is 15 because what's left is right there. Okay? Try this. Second row, first column. So 0 times 20 is 0. 2 times 30 is 60, positive 60. And negative 1 times 55 is negative 55. And 60 minus 55 is 5. Cool! What I just found out is y is equal to 5. Negative 1, negative 1, 1. Multiply this last row times the first column. Negative 1 times 20 is negative 20. Negative 1 times 30 is negative 30. 1 times 55 is a positive 55. Negative 20 minus 30 is negative 50. Plus 55 gives me another 5. So I just found out z equals 5. Awesome. Now, if you're thinking, but Dick, that's like a lot of work because we went through a lot of work to find that inverse, right? I'll agree with you. If you don't know the inverse, this is finding the inverse and then using it. That's more complicated than just solving it in the first place. But suppose I had a problem like this, where I say, here's this matrix, here's the inverse, and here's a system. 1, 1, 2, check it out. 1, 1, 2, negative, negative, negative 3, negative, negative, negative 3. This inverse, this matrix represents these coefficients. Then all I need to do to solve it is take the inverse, negative 2, negative 1, 1, 5, negative 1, negative 1, 0, negative 1, 3. Take that inverse matrix and multiply it by the solutions to the system. Now, the great benefit of this is suppose I had a situation where I had 3 different equations and I changed the answers. That's a great way to do this. Or suppose I only needed one of these things. I didn't need x, y, z. I just needed one of them. Well, I could find x by taking the first row times the first column. So check it out. Negative 2 times 4, that's negative 8. Negative 1 times negative 5, that's a positive 5. 1 times 2, that's a positive 2. Okay? Second row, first column. 5 times 4, that's 20. 3 times negative 5, that's negative 15. Negative 1 times 2, that's a negative 2. Okay? Bottom row times that column. Negative 1 times 4 is negative 4. Negative 1 times negative 5 is positive 5. 0 times 2 is 0. And if I combine these, remember, this is just a sum of numbers. This isn't a matrix anymore. Well, it's a matrix, but these aren't 3 different things. Negative 8 plus 5 is negative 3, plus 2 is negative 1. Next line, 20 minus 15 is 5. 5 minus 2 is 3. Next line, negative 4 plus 5 is 1. 1 plus 0 is 1. And all of a sudden, I know x is equal to negative 1, y is equal to 3, and z is equal to 1. And I've solved that matrix using an inverse matrix. So if I know the inverse matrix already and I don't have to find it, this is a great way to solve it. So the back half of this focuses on finding inverses and using them to solve equations, also confirming matrices, confirming inverses, where you multiply a matrix times matrix and you get an identity. That's it, guys. Moving on, next time we have partial fractions. See you then. Bye-bye.